Hey, what's up guys, my name is Cherno. Welcome back to another episode of Cherno Fixes Your Code. I'm in code review. This is the code review series, right? This, of course, is a series in which you guys send me your code and I take a look at it. I give my thoughts, I give some suggestions to people learning programming and all of that, and hopefully it's just a good time for everyone involved. Last time we took a look at a ray tracer. I'll have that video linked up there if you are interested. And today we're going to be diving into a little bit of a blast from the past. We're going to be talking about a game that I actually remember from Windows Vista. Except that someone's made it for some reason. I don't know if you remember Inkball, but it was a game that came bundled with Windows Vista. I made a version in C++ with SDL2. I have a fair bit of work and open source experience, but not very much in C++. More C#, JavaScript, TypeScript, Python, and Java experience. This is actually something that made me want to take a look at this project, because I know a lot of you are familiar with other languages. You're not just learning programming for the first time. I think that it's probably a minority who have never done any programming before and they're starting off with like C++ or C. I mean, I'm aware that that does get taught in university, like a lot. I remember learning C in my introduction to programming class. However, these days, if you're self-taught, I feel that if you're into games, you're very likely using C# with Unity or trying to make some kind of Java C# game kind of standalone. Or if you're into like web development and that stuff, you're probably using like JavaScript, Python, that kind of stuff. In fact, Python is very much useful outside of web dev. I know a lot of people who started learning how to make games using Pygame and Python. So the point being that there's all these different languages out there, and if you're more or less familiar with them, but you're coming to C++, there's a lot that you may have to learn. In fact, this is my personal experience as well. I started learning programming with Java and I used that for several years before working at EA using C++. There are a lot of differences between those languages and there's a lot to learn when you come into C++. So I'm excited to take a look at Benjamin's code ultimately and see if maybe I can give some good tips to all of you guys who are also in the same boat. Project is completely playable, includes 5 levels in a homemade binary format that is deserialized at runtime. That's cool. It doesn't use a game engine and it was more a project for learning than anything else. Okay, cool. I wanted feedback on my C++ and project architecture, especially the way I handled deserialization and manage the lifetimes of SDL objects. Okay, so those are 2 things that we will take a look at. If I were to continue development, I'd probably better highlight the separation between level and playable level. Again, we'll find out what that is in the future, as well as set up a less finicky build process. Yeah, the build system is definitely something that is difficult to kind of wrap your head around if you're coming from different languages, because C++'s build system is, well, it doesn't really have a build system and everything else that it has is kind of all over the place. So we'll take a look at that as well. Currently, all dependencies are statically linked. That's good. And it's compiled with MinGW on Windows. Okay. We might try and use Visual Studio because that's what I'm going to do. You may be aware that MinGW doesn't support std thread very well. This introduces some compilation headaches. Yeah, you should probably just use Visual Studio. I apologize if you're on Windows, right? I apologize for the difficulty in compilation. Okay. And if you do decide to do a code review, I would not be offended if you don't run the game. I don't even think I have any multi-threaded code anyways. Okay, so no need to really have threads, I guess. There is no need from a performance perspective. Okay, for multi-threaded code. I see. Okay, the link to the repository. Inkball. Let's take a look. For those of you who don't remember this is Inkball. This is the game that we are talking about that I remember on Windows Vista. In fact, this logo over here brings back memories. So taking a look at the repository, which I will have linked in the description below, let's read the README. It's an Inkball game that's still in development, doesn't use a game. Okay, cool, looks very similar. I have working collisions and you can draw an ink trail which balls interact with. That's also cool. To do level creation, maybe building. These are not full instructions. All depends statically linked. GCC C++ 17. You can see dependencies and dependencies. We'll take a look at that. And okay, so CMake. Okay, so it's built using CMake, so we should have no problems hopefully running this inside Visual Studio. Needs SDL2, SDL image, and TTF. MinGW threads on Windows as well. Test it with 32 bits of all libraries for exporting. Okay, I wouldn't recommend really working with 32-bit these days. I mean, I would just go with 64-bit for everything pretty much. We're in 2021. But aside from that, I'm excited to take a look. But first, I want to mention that this video is of course sponsored by Skillshare. For those of you who still don't know what Skillshare is an amazing online learning community where millions of creative and curious people from all around the world can come together to browse their incredibly dense and beautiful library of classes on pretty much any topic and learn new skills. Ultimately, there are 2 things that I really love about Skillshare. First of all, the variety of classes they have. I mean, literally anything you're interested in, photography, videography, like illustration, even stuff like business management, productivity, marketing, they literally have videos on absolutely everything. But also, it's not just about quantity. The quality of these videos is also exceptionally high. They're really kind of short and bite-sized. They're easy to digest. They're easy to get through even if you don't have much time left in your day. And it's kind of formatted in a way that just keeps you learning. It's really easy to take a look at like a 30-minute video and just put that on the back burner because you can't seem to find the time to sit down for that amount of time. But Skillshare's format is mostly extremely bite-sized, meaning a lot of the videos are like 5-10 minutes long, which of course makes it easy to just find some time during a break, sit down and keep yourself constantly learning, which honestly has so many benefits for your brain. Skillshare is offering the first 1,000 people who click the link in the description below a 1-month free trial of Skillshare Premium, where you'll be able to literally take a look at any of their classes and see if you like them or if there's something there for you. So definitely check them out, go ahead and learn a new skill, and huge thank you as always to Skillshare for sponsoring this video. So as usual, the first thing that I'm going to do is clone it. I'm not going to bore you guys with the details. If you have no idea how to obtain like repositories from GitHub and all of that stuff, take a look at the other code review videos because they go through the setup process really well, and I'm probably going to start skipping it from now on because I think you guys get the point. Quick little tip though, if you have accidentally closed the Explorer window like I did and you still have the command prompt open, you can just type in start dot, which will just open a new Explorer window in the current directory, which is very useful. Let's go ahead and cmake this. Cmake error at cmake lists, add subdirectory, a given source. Okay, so I actually am going to focus a little bit on the build system stuff just because this person mentioned that they are coming from, you know, other languages into C++, and this of course is very relevant to C++ and will hopefully help a lot of you guys out. So add subdirectory given source. So what's going on here is CMake is trying to obviously add this directory as another kind of CMake project, but it clearly just does not exist, or at least it's not an existing directory in this case. So this is a little bit unfortunate because, I mean, we know from the dependencies that min.gw threads specifically seems to be an actual dependency, not like the rest of min.gw, I guess. I am going a little bit off the book here because I'm trying to compile this with Visual Studio. However, yeah, it should obviously exist here and it does not. So what can we do about this? So over here, it looks like we have this min.gw std threads kind of repository, which looks like it is a C++11 threading class implementation, which are still currently missing, which is what Benjamin was referring to. It's also a header only library. So this is something that we would ideally want to use in our repositories. And I imagine that's probably what the original author of this kind of inkball, Benjamin, this is ultimately probably what he was using. So let's talk a little bit about how we can actually set up this dependency in C++ a little bit better instead of just obviously providing people with a project where they download it, they run it, and suddenly this does not exist. This, in fact, is a perfect use for Git Submodules. So what a submodule is inside Git is basically just another repository, an external Git repository that you can include as part of your project. So you're basically just creating a link to another Git repository within your repository. The code isn't actually stored as part of your repository, it's external. And of course, you have some extra levels of control there. You can pin a specific revision, like you don't have to be always on the master branch, on latest code, whatever. You can have a different branch of the repository. You can have a specific commit. That's all perfectly normal. So what I recommend you do for this is just add this repository as a submodule. Now, of course, you might be using actual min.gw. If you've installed that on your system, maybe you don't need to do anything like this. However, this is a good example to kind of show how to do this. So if we go back a directory, I'm just going to type in git submodule add. Now we know here that because add subdirectories is used, it's actually looking for a CMake kind of project, right? This has a CMake list file. So that's kind of important because that means it's going to work. So back over here, I'm going to do git submodule add. I've pasted in this URL and then I'm going to give it a folder or like a path to basically check out this repository into. So we know that it's going to be somewhere here. I mean, we're already in Inkball, so just basically include /min.gw is where we want to check out this repository. Let's hit enter. Aha, the following paths are ignored by one of your git ignore files. So it looks like this person has deliberately not committed this. Let's take a look at the git ignore. And sure enough, we have the include directory being ignored. Okay, so I think this is a case of this person has checked out the repository but doesn't want it to be committed as part of their actual like Inkball repository. But again, this is a perfect use for submodules. So what we're going to do is just get rid of include from here and like, I mean, well, we'll keep lib there, I guess. And then we'll try and do this again. It's going to clone all of this. We should now have that at this path. In fact, if I just go ahead and open that real quick, you can see we have this entire MinGW threads repository. So let's try and run CMake again. We'll probably have to like delete all the stuff here. So let's go ahead and use that wonderful start dot thing. And let's go ahead and just run CMake again. Okay, so no more errors, and we in fact have build files that are written. So yeah, that is how submodules work. Now, the actual submodule information goes into this Git modules file. So if we go ahead and open that real quick, I'll just drag this in, you can see that we actually have this include MinGW and it's set over here. And if you had like a particular branch, all the information will kind of go over here. And to obtain that, if you're cloning the repository, once you've actually pushed the fact that you even have a submodule, you'll need to do that kind of recursive thing. That's what I usually do when cloning any Git repository, just in case they have submodules. You can just clone recursively to make sure that you also retrieve all of the submodules. Okay, cool. So now that we have those build files, let's actually go ahead and try and compile this with Visual Studio. Okay, so it's actually automatically created x64 as the target architecture. Let's just go ahead and hit build. And we have a whole bunch of errors because it can't find SDL. So I'm assuming there's no SDL in this repository either. All right, I'm not going to bore you with this. You should also add SDL as like a submodule, or maybe even commit the built binaries if you want for each platform that you support. I'm gonna go ahead and just download the binaries for SDL and the header files for SDL, set all of this stuff up, and we'll be back. Okay, so I've gone ahead and added SDL. All of that seems to be okay now. However, we have a bunch of other errors. Let's take a quick look at them as a learning example. So first of all, use of designated initializers requires at least C++ latest. I'm not sure if this is something that is fine in like GCC, G++. However, to use like .x and all of that stuff inside Visual Studio's compiler, it seems that we need to be using the latest C++ version, so like C++ 20 basically. So if we go into like C++ and I never remember where this even is. Okay, it seems to be in general. C++ language standard, you can see it's set to C++ 17, which he said that it supports, but clearly it does not, so we have to use C++ latest, and these errors should go away. Quick little note as well, compilers differ greatly. I mean, maybe not greatly in the grand scheme of things, but there are definitely differences between compilers. So make sure that if you are kind of working on a serious C++ project, especially if you support more than one kind of toolchain and you want it to be kind of multi-platform. I mean, even if you don't, just as a C++ developer, it's obviously better to not specifically use things that are specific to a particular compiler. And in fact, I think I saw one other thing here. So let's go ahead and try and compile this one more time. I mean, one of the things that separates like a junior C++ developer from a senior C++ developer is the fact that the senior developers are a little bit usually more aware of the fact that, there are other compilers out there and the differences between them, because that stuff is definitely something that you don't typically come across if you're just working kind of in the beginning and you're not really that experienced. Okay, illegal reference to non-static member here. Okay, so type of. So type of, I think there were errors to do. Yeah, so type of is not a valid template argument. Type of, which, I mean, I think it's type of in like C#, so maybe that's where that's kind of leaking in. Type of is a GCC, like G++ specific keyword, right? So it's not actually portable. The portable version, as far as I'm aware, is decal type, right? So if you use decal type, I better not be embarrassing myself. So decal type, and I just looked this up to be safe, decal type is standard across C++ since C++ 11. And again, what it will do is literally look up the kind of static compile time type of whatever numblocks is, right? So if numblocks is a uint16t, that's effectively what we're doing here. We're just figuring out the numeric limits of uint16t. However, of course, well, that's 64 because I'm used to writing that, but uint16t, right? So instead of writing this, we can kind of use a variable for that instead, or at least look up the type of the variable so that if we decide that this changes, we don't have to go back and adjust all of these numeric limits. So in general, it's a good idea, but just make sure that you're, of course, using the more kind of portable keyword and the keyword that is C++ standard, not just specific to GCC. Okay, and the final error looks like cannot open MinGW. I don't think we need that because MinGW threads is a header-only library that we seem to be using. So I'm just going to go ahead and go into the linker and probably just get rid of this. And hopefully that will just work. Okay, and we are good. Let's go ahead and try and run this. Okay, we need all of the DLLs. So clearly they're not statically linked, these libraries. Okay, so I've just pasted in literally all of the DLLs that come with all of the SDL libraries that we've used. Let's go ahead and hit F5, and we finally have this game. Oh, wow, that seems to be lagging a bit. Okay. When I move my mouse, it doesn't do anything. Oh, what's this? Oh my goodness. So game over really is game over because look at that memory leak. Escape for menu, still happening. Select level 1. Okay, stabilized. And then what happens when this goes in here? Memory leak time. Okay, so that's one thing I think we can definitely fix. Seems to be some kind of just massive constant allocation of memory every frame in the menu screens, which is a bit odd. But other than that, let's ignore that and see how long I can run this for without crashing. But yeah, the other odd thing that I've noticed is that every time I move the mouse, the whole game freezes. So that's a bit weird. Oh, cool. Like, okay, so I can draw like that. Let's try and actually get this in. It makes it kind of annoying to play. I mean, I don't know if that's a feature because like it doesn't seem to be like maxing out a core or something, right? Wait, what am I supposed to do with this? Why is it not? Let's try level 4. Ooh. Nah, this is like practically unplayable like this. Surely it's not meant to be like this. I don't remember what the Vista version was like. But other than that, yeah, like pretty cool game, I guess. I'm interested in how the drawing is made. I mean, I'm assuming it's just a bunch of lines. But anyway, that gives us a few things to take a look at. And also in my notes, I have that Benjamin wanted feedback on C++ and project architecture. So we kind of talked a little bit about the C++ build system, and then also the way I handle deserialization and manage the lifetimes of SDL objects. I feel like managing lifetimes does need a chat considering that memory leak, but also deserialization is something that we'll look at. Okay, but the stuff that interests me right now is the memory leak, because that's kind of an issue, obviously, and also the weird kind of freezing when we like move the mouse. And again, I don't know if that's a feature. I mean, it's possible it is, but to me it seems like some kind of weird bug because I think it makes it really annoying to play. So we'll definitely take a look at that. Okay, serialized levels seem, I don't know why we have this open. Oh, because we fixed all the decal types. Okay, well let's take a look at the general kind of structure and we'll work ourselves into fixing that memory leak. So okay, we have the main, it starts up a game on the stack and then hits game.play. Pretty you know, normal architecture. This seems to be a very common architecture, which is fine. I have nothing against this. You know, it's also worth kind of pointing out whether or not you actually need this, and if you can maybe just have like a, you know, gameplay or like start game function and you don't need to like make an object out of it. But again, the reason why I think it's okay is because, you know, a lot of people coming from C# Java are obviously very much into object-oriented programming, and I don't know, I don't think there's a huge deal with that in this sense. You know, overall, I think object-oriented programming, maybe I should make a separate video on this, but I think it's okay. I just think that you can't rely on it too much, and you should just be aware of the fact that not everything has to be OOP. But, you know, I don't think OOP is specifically bad, especially for a lot of cases like this. Okay, anyway, so we create a window. I'm not going to, you know, dwell too much on this kind of SDL code. Load level from path. Okay, so I guess we can take a look at the deserialization. So deserialize level information. First thing I'm going to do is actually take a look at what the levels look like. So they're in binary, right? So let's go ahead and just see if we can open this. My favorite binary editor, by the way, is HXD. I think I've mentioned this before. But let's go ahead and drag this in just so we can take a look at the format. Okay, how big is this file? Looks like it's 1.18 kilobytes. All right. And then we have, yeah, ink level looks like the header, and then a bunch of random stuff here, which I imagine is probably the positions of things. So let's take a look at how we are actually processing that. Load level from path, deserialize level information. We have a bunch of vectors, blocks, pockets, balls. I'm assuming we just read like a size argument. So this takes in a buffer immediately. So does that mean that so level deserialization read takes a path and this. Why does it take this in? That's interesting. Takes the game in because it needs the game. Well, apparently it needs to pass the game into deserialize. That's probably the target of the data maybe. But anyway, we have a max size, which seems to be like 10. What's this? 10 kilobytes. This max size isn't actually used anywhere. So I guess that's relevant. Okay, we use a C API, which is fine. You know, I would probably do read binary though, RB. I'm not sure. I don't remember the differences between all of these, to be honest. I guess R is also fine because it's not like it's text specifically. Maybe it's binary by default. We get the file size. Cool. We make a new local buffer of that size, and then we put it into here. So again, you know, reinterpret cast, changing char pointer to unsigned char pointer. That's not really necessary for anything. I mean, to be honest, there's no reason why you couldn't have just set it up like this by default. But the other thing is, what I would recommend is instead of using unsigned char, just use uint8t, right? So uint8 underscore t. It's the exact same type as an unsigned char. In fact, if we take a look at this, it's going to actually be an unsigned char, right? But it's a little bit more portable, right, across platforms, across compilers, and also obviously it has the actual number 8 inside the type, so you know how big it is. And I think that's important, right? So I would change it to this. But again, you know, it's when you're dealing with pointers and memory, the type that it is kind of not really that important. It's you know, it's important for like pointer arithmetic and stuff like that. If you end up doing, you know, advancing the pointer forward or doing any kind of calculation with the actual pointer value. However, in this case, you know, it doesn't really matter. And I would do this. You don't need that reinterpret cast. Okay, so a few things that future Cherno noticed, me while editing this video, is there's actually a number of problems here in this function. First of all, we're opening this file here, but we're never closing it. So fopen gets called, we have this fp, which is a local variable, we read all the data, but we never close it. So as soon as we've read the data into the local buffer, which happens here, we can and should close the file by just calling fclose. That's very important, otherwise the file remains open until basically our program terminates, because this pointer then gets lost. The other problem is this local buffer, right? This local buffer gets allocated over here using new and then passed into this deserialize function. This deserialize function then reads from this buffer pointer, but it doesn't delete it ever. So this is another memory leak, right? We need to make sure that we either delete it over here. However, I probably wouldn't do that just to keep it simple. Instead, what we could do if we go back here is once we have deserialized this, we could in fact just delete this, right? You could just do delete local buffer and make sure that you're actually cleaning up your memory. Otherwise, this is just a memory leak where every time you deserialize the file, not only does the file remain open, but you also just never free this memory until your program terminates. I see you love throwing exceptions, which not something that I'm personally into, but it's okay, you do you. Okay, deserialize. Let's take a look at this. So again, you know, and then we reinterpret this into this. You know, there's a lot of stuff going on here. Like, why take in a raw buffer? You might as well take something in that is in this particular format. Again, you know, pointers are pointers. Pointers are integers that contain memory addresses. The data at that pointer is completely irrelevant to the pointer itself. They're two different blocks of memory, literally, right? Again with the exceptions. So, okay, so we try and figure out whether bytes is less than the size of level header, in which case obviously it's not even there. I feel like these code review series, like videos, they're just getting deeper and deeper. I mean, I could literally sit here for hours taking a look at this. I don't know if anyone will be interested in that. So I might just kind of speed up a little bit, but I don't know. I'm always kind of after feedback as far as what this series is. So definitely let me know in the comments if you think this is fine or if I should speed up. Okay, bytes needed. Yeah, so we figure out how many bytes we need to read, I guess, and then so we have the gist of this is we have a buffer of memory which we've kind of cast into this header, right? So that we can actually interpret it like that. Might be worth making a little video about binary serialization in general, but we basically go through this buffer. Now we have the head of the actual data, so we've advanced the header amount, and now we're looking at the actual information of what comes next in the file structure. So in this case, we seem to have block information, right? And block information just contains an X and a Y, right? Using alignment here, which is nice as well. But X and Y and their floats, right? Again, that means that we basically have a number of blocks that is defined in the header, and then all we're doing here is we're iterating through and apparently making doubles out of them, but this takes in doubles as well. So I thought these were floats. Interesting. Oh, well, yeah, I guess you're just casting them implicitly to doubles. Sure, storing those floats. Again, I don't know why they're doubles here. They're stored as floats anyway. Maybe you're using doubles for some kind of extra precision in collision detection or something. I'm not sure, but I'd probably just use floats for everything. That's just how I roll. Okay, so then we go through the pockets. I don't know what pockets really are, but same kind of situation. And then based on the pocket color, which is an enum value, 1, 2, 3, or 4, we basically set some kind of texture name, and I guess that's a texture that we load. Yeah, this is all pretty standard. I don't really have any problems with this. I like the fact that you've used structs a lot. I think that when dealing with serialization in binary, it's important to use structs like this, right? So instead of having to deal with all of these loosely, you can just take that buffer, you know that it's supposed to be like a header, and then you can basically just, cast the buffer at a particular offset if needed. In this case, it's from the beginning of the buffer to be like a level header, and then that's it. You basically already got all your struct with all of the accessible information. So the fact that you're actually using structs here you know, extensively for everything is great. I think that's the perfect way of doing it. The only other thing that I would do, because like when it comes down to it, binary serialization is obviously very error prone. Yeah, I mean, like there's other stuff we could talk about, like big endian, little endian. I don't think that's a huge concern. You know, if you're mostly working in like an x86 64 kind of platform, you'll be a little endian and you don't really have to worry about anything. However, the one thing I would probably do here is just make extensive use of asserts. Right? So just literally every step of the way, assert everything, make sure everything is correct. You're throwing exceptions kind of instead, which is okay, but I just prefer asserts personally, and it means that you can kind of take away all of this stuff and clean it up a little bit when you're actually building like in release and stuff. Again, not that exceptions that don't get thrown are particularly expensive, but it's just a little bit cleaner in my opinion, and it helps you kind of assert a lot of conditions, which you're doing anyway. But otherwise, it looks pretty good. I mean, you're filling vectors with values, returning them, which may not be the best idea, but I think that overall, this is totally fine, and yeah, looks pretty good to me. Okay, so let's get real. Is it just me, or do you really want to find out what this memory leak is? Because that's the thing that's been bugging me. So let's talk about how we can track down memory leaks. So there's a few things you can do. I mean, the simplest way probably is possibly, I don't really do it this way that often, but you can actually take a look at, you know, memory usage. So you can find memory leaks with this using the performance kind of profiling tools inside Visual Studio. Let's have a go at doing that because I don't think I've done this very often. Oh yeah, we'll get rid of this because I had two of them. Let's go back and yeah, this is fantastic. Let's go back to our performance profile, our memory usage, and hit start. There's a few other ways, obviously, and I could kind of show them, but I'm just interested to see. So we need to do like a game over, right? Oh, I remember this actually. I have definitely used this before, quite a bit. So we can take a snapshot, like I think before or after or something. And yeah, there's the memory leak. So let's take another memory snapshot. And what it's going to do is just show like where the memory is being allocated, basically. So let's kind of stop collection here. It's nice to do it before and after because you can kind of see, I guess, where like the memory has gone to. But I think that it should be probably good enough to just take one snapshot when the memory leak is happening, or at least it should show, you know, what has allocated a large amount of memory, because clearly whatever has allocated it, it's used more than the entire rest of the program, like by an order of magnitude probably. So it should be pretty easy. So you can see that during this we had 9,000 allocations. Here we have 58,000 allocations, clearly a lot more. Let's take a look at that. So we're basically just, I don't know if we can look at a hot path here, but let's go through this. So you can see that most of the allocations by far are coming from the play function, and this is basically your call stack, right? So it's coming from drawing, which we kind of expect. Get string size, interesting. And then SDLTTF, get string size. So what we are probably doing, if I had to guess, is, can I go to this function easily? Is we're probably loading the font file repeatedly or something. I don't know what else would be causing a memory leak. Let's go. Okay, so what is this? Get string size. Let's just go to get string size and let's take a look at this. Okay, so here we are opening the font inside this function and I guess never releasing it from memory. Oh, it's happening here as well. Oh, okay, but here we close it. Okay, right. So here we close it, here we don't. So I'm assuming if we did this, it would in fact fix the memory leak. Obviously, we don't want to be, I'm just testing this to see if it fixes the memory leak or not. How do I get a game over or something? Man, this mouse thing is so frustrating. Is this, please someone tell me if this is intentional. I might send him an email. Oh, we crashed. We crashed. Oh, sorry, we use it here. Wow. Cherno review. More like Cherno breaking people's code. It was working before me. Yeah, please, I need to probably send an email and figure out. I just can't deal with this if this is intentional. This is nuts. Okay, the orange ball is heading in. Okay, yeah, that looks stable. So if we take a look at this, obviously we're not allocating memory. Now let's have a quick chat about this though. Do not open font files repeatedly here, right? Now I can see why you might be doing that, right? I mean, if we take a look at this, we're not just opening a static font file, right, over and over again and then closing it, right? We are doing it at a particular size. Now, the thing with these fonts is that, again, unless we're doing something moderately fancy like signed distance fields for our font rendering, we actually need to rasterize our font at a particular size, right? So it's possible that multiple sizes are being passed into here. However, this again is something that you definitely should. I mean, you know, if you had more time maybe for this, it might be, and if you're actually investing into this game and you're going to be developing it for a while or setting up an engine, which I know this isn't, but ultimately you probably want like a resource or an asset manager that will be able to take care of this. But what you could do here at the very least is just cache this actual font, right? Because again, opening it, closing it, like apart from, you know, well, in this case, causing a memory leak, it's just going to be very bad for performance, right? There's no need for us to actually do that. So what we could do is cache it instead. Now, again, the problem is that we have a size here, right? So it's not as straightforward as just like, you know, let's just not, you know, if we were opening it at a constant size, then that's easy. We could do something extremely simple, such as just make it like a static up here, right? And then if you make it a static up here, I'm just failing today. If you make it a static up here, you can set it to null pointer and then just do basically like a lazy load, which is us being like, basically the first time it's used by whatever it's used by, we don't care. We don't need to explicitly initialize it. We can just basically wait for it to be used. And then the first time it's used, we set it to something like this, right? And then of course we don't need to close it. And if we wanted to, we could close it as like part of our shutdown. I don't know if it's even necessary to do this, to be honest. If you're just terminating the application, your operating system will obviously reclaim all the memory. But to be nice, I guess you would want an initialization and a shutdown or something like that. But anyway, point being that you could just do that, but that doesn't work for size, because in this case, this has nothing to do with size, meaning that obviously it's possible that you might want something a little bit different, in the sense that like you might want like some kind of unordered, it doesn't matter, unordered, ordered map. I'll just use a map to be a little bit cleaner, but you could have your size and then your actual pointer, right? And then all this is your little like font map. And then that way you can check to see if the key, which is size, exists within that map. If it doesn't exist, you load the font and you cache it in this map, right? And then you just use it. But if it does exist, then you just retrieve the pointer from the map and obviously everything's fine, right? So you could do something like that. And then you could loop over this map and close all of them if you needed to, but that's kind of how you could make it work with all of this. And again, if you had an asset manager that would kind of handle all of that behind the scenes, all you have to do is ask the asset manager for this font for a given size. And then that's kind of, it's up to the implementation details of the asset manager to figure out how it kind of functions, right? And again, if you're running out of memory and this isn't used, it could start cleaning out assets. Anyway, lots of obviously very complicated systems we could set up for this, but you know, at the very least, I would do that. But to fix the memory leak and to keep this code as simple as it is now, I guess we would, even though it hurts me, I guess we would just keep loading it every frame, every time we write text, but at least close it, you know? So that's kind of, yeah. Looking through the rest of this code, I don't see any other major problems. So we're drawing a bunch of lines here. You know, you're passing vectors by value, which you definitely shouldn't be. So just keep in mind that vectors, obviously, if vectors get copied, then they will actually do a heap allocation to contain all the memory. So it's not really about memory per se, it's more about performance, because dealing with a large amount of memory or allocating memory and then freeing it and stuff like that, that's obviously going to take up CPU cycles. So we can kind of avoid that by just simply referencing this instead, especially if it's kind of, well, in this case, obviously it's just read only, just reading the data from there. You just need access to the vector. You don't need to actually create a whole new copy of the vector, which is what your code is currently doing. So just remember, basically anything that is sizable, try and pass it by const reference. Now, this doesn't apply for things like vector2, even though it is 2 doubles, which is 16 bytes. Like, that's not really that big of a deal. 16 bytes to copy, no worries. The problem isn't really the memory that we're copying. It's the fact that copying a vector, like the vector copy constructor, you know, needs to create a new vector. And creating a new vector means we have to do a heap allocation to contain all of the elements within the vector. So it's more or less the code within the copy constructor and that whole kind of, you know, creating a vector situation. It's the code there that's doing the allocation that's the bad thing, not the fact that the vector itself takes up space, right? Kind of like a vector2 would, 16 bytes, but it's okay. Same with like string. Again, you know, for stuff like text, the thing with this is that, you know, if we're reading this text, like what you're doing here is copying the string, which again is not really ideal, because if you take a look at this, right? I mean, let's use this as a little case study. And I think I mean, I really want to fix that other bug, but yeah, these videos, man, these videos are just so long. Anyway, what am I even looking for? Let's actually, okay, VA find references. Okay, so write text. So for example, you know, we're writing text over here. You know, what is this? Okay, we have like press escape for menu, and then, yeah, we've got like a bunch of, is this actual, oh, subtext is what we're writing. Yeah. So subtext is, I don't know what this is, to be honest. But anyway, subtext, we write like, for example, press escape for menu, right? This gets written immediately, meaning that like, you know, in this function, in the scope of this function, this is all single threaded, right? You don't need to worry about actually copying the string in the sense that the string's lifetime is tied to this function, right? Which means that we have to be done with it or copy it by the time this function is terminated, because this memory will in fact be freed, right? So you have to kind of keep that lifetime in your mind. So that being said, we come over here and we go to render text solid. Now, what does this do? Well, this takes in a const char pointer, and it obviously uses it immediately internally, right? It doesn't reference it and do something, it will actually draw it, right? I don't know exactly how SDL works, but my point is that it will take that text, probably copy it into some buffer if it needs to, and deal with it. Meaning that basically here you can free the string memory, right? As soon as you've given it into here, and this is how most kind of renderers work, right? It has taken it, it's done what it needs with it, it's copied it if required. And then that means that, again, it's not your responsibility to keep this text alive, you know, for like what, until the next frame or something? No, right? You can be done with it immediately. So what that means is that we don't need to make a copy of it or anything like that, right? We can just kind of use this existing memory that, I keep losing everything. We can just use this existing memory that we created here, right? For this press escape for menu. Why have this duplicated in memory? We don't need that. We can just have it in memory once, which is here. And in fact, this is probably going to be like a const char anyway, but we can have it in memory in a particular place, and then that's it. So what you should do instead, and of course, like in this case, it is a const char, but if you're, you know, maybe using like, I don't know, string stream or something to like, you know, add in, like, for example, you were displaying the score. So obviously that's kind of a dynamically generated string. It's not just in read-only memory. And then in that case, obviously, you know, you would be kind of copying it. But again, if you know the lifetime, instead of doing that, it'd be much better to use, to either pass it by const reference or to use like string view, right? You're using C++17. So you can just use string view, which basically just means give me a pointer to like the string and to its end, I guess. And then that's kind of it, right? So again, you're not copying the string, you're just using the string that you've already created over here, right? Because then you get into this habit of like, okay, but if I create functions, I have to pass stuff into those functions, which means that it's almost like the more functions you make, the slower your program becomes, because every time you call a function, you're copying everything into that function that already exists in the parent kind of calling function. And that, of course, is not something that we want to or need to do, right? So just keep an eye on that. And again, coming from something like Java or C#, it's kind of easy to just not realize this, because if you have a string or you have this vector, right, which would be like a list in Java or C#, like objects in those languages are like pointers essentially, right? They're not actual kind of stack allocated objects that you can copy. If you were to write this exact code in C#, and it might be something like public void draw lines, and then here maybe you have like some kind of list, you know, how would you write this in C#? Well, it would basically look like this, right? So by doing this though, again, list is basically being passed as like a pointer or a reference, not like this, if you were to kind of compare it to the C++ equivalent. And that's another thing that people coming from Java, C# don't realize in C++, that like, you know, you don't have to use the new keyword everywhere. And you know, classes like that don't really translate. It's kind of like a struct, I guess, in C#. Structs in C# are also kind of value-based, not reference-based. But anyway, the point being that to convert this properly, you know, you would actually have to add in that pointer. But instead of doing that in C++, we can just add a reference. And again, I guess pointer reference, same kind of idea. But the point is, this now means that it will effectively work like it would in C# or Java, right? If you were to pass in a list into a function, in the sense that it doesn't copy the list, it just references it. And that's how you achieve that in C++. So that's another really important thing to get your head around if you're new to C++. Okay, so the final thing that I want to take a look at is this weird mouse lag thing, right? And again, there's so much we could take a look at here, honestly. I could probably sit here all day and just go through this line by line. But in the interest of time, let's see what's causing that, because it's very weird. Now I'm going to look at the game loop, because strangely enough, again, I don't think it's actually a frame drop, because if it was a frame drop, then we'd probably see the CPU usage go up, right? I think these frame times are fine. So let's go ahead and look at the actual loop, right? Because that's kind of the first, this is the entry point essentially into every frame. So okay, so the first thing we do is we check for events. This is fine. So if not, should quit. Don't know if you should necessarily handle this again. I guess if there's a quit event, then that will come up maybe, but it doesn't look like it would. So I don't know if we necessarily need to like check that, but we poll all of the events, we retrieve them, then we go handle event, which, what does that do? Okay, that sees what it, oh, right. Okay. So one of the events could be a quit event, which then means you don't have to keep processing events. Okay, fair enough. And then we do all of this stuff. Mouse button, again, handle mouse move. I don't think this, I guess it depends what like playable level I think is the actual level. And what was that? Handle mouse move or something. Okay, so if it's the left mouse button, then we draw like this trail, which yeah, looks like it's just a bunch of lines. Okay, sure. Yeah, I don't really, is drawing trails, so surely that doesn't stop the balls from moving. Is drawing trail. That seems very local. Okay, sure. I guess it's no, it's private. Anyway, so yeah, what could it be? Why is the time changed inside the event? Okay. So we get the last equals now, and then we get that, and then we calculate now minus last. But that's going to be like 0. So if we go through events and we update the time to the current time, then we do this one little thing, which clearly takes no time at all. Then we get now again. So last is equal to this. And then we get the difference. This is going to be like 0. This is probably why, because we're effectively doing this. I mean, if you want it even more clearer, we're effectively just doing this. Right? So the point is obviously with delta time to try and figure it between frames. So we want to see how much time has passed through the entire frame, including like presenting the rendering, including waiting for vsync possibly. So I think this is the culprit actually, because if a delta time is 0, nothing will move. Okay, you've got a max time step. That's good. And looks like you're updating more if you need to. This is all pretty good. Sure. Yeah, let's try removing this. That's my initial suspicion, because this is just evaluating to 0. And obviously if we keep getting events, yeah, there we go. That's fixed. If we keep getting events, then we're not going to move anywhere because we'll always be like, literally you'll only get a proper delta time if there are 0 events. That's how it's currently set up. And yeah, no memory leak. Okay, cool. I haven't checked out all the levels. I don't know if we will, but yeah, overall, pretty cool game. I think that, you know, for someone who's coming from other languages, you've done a pretty decent job in using C++. Obviously, there's a lot of things I would personally change, but it's hard to differentiate between stuff that's actually, you know, objectively good. You know, I've tried to point out stuff like that, like not copying strings or vectors, making sure that you pass by reference, when needed, because you do sometimes with these pointers, but that's because the objects are like that. Obviously being, you know, creating a cache for your text stuff and possibly an asset manager in the future. But overall, like, yeah, this looks like pretty decent code. You clearly seem to more or less know what you're doing. Again, I'll just assume the memory leak was like a bug. And that just something that you accidentally missed, although you have done it in 2 different functions. No, actually, sorry, it wasn't a leak here. But again, opening, like, I just have a problem with opening this file, like every frame potentially, reading it, rasterizing it, you know, well, actually, I don't know if it gets rasterized here. It might it might actually rasterize each character as it needs it when you actually try and render a particular text string. That's what I'm assuming it does. I don't think it just immediately sets up like all of the ASCII characters or some kind of character set into an atlas immediately, but who knows? Anyway, the other thing that I like is that, for example, your level select menu actually uses the directory iterator from C++17 to find out which levels we have, right? So it's all very dynamic. If the file exists there, then you can load it basically, which is pretty cool. I mean, if we went to our levels and we duplicated this and we called it Cherno, then I'm assuming we would get a level called Cherno. And there it is. We have a level called Cherno, which is the same as whatever level I copied, right? So that's pretty cool. A little bit more dynamic. I like that. You also seem to have all of these deleters. SDL window deleter. What's the point of all of this? Because you did mention you wanted me to take a look at like STL lifetime stuff. But what's the... Oh, I see. Okay, yeah, okay, that's interesting. So you've put STL window and STL renderer into a unique pointer and specified a custom deleter. Right, because obviously STL is all like C-based and you have to explicitly essentially have a destructor that calls this. I guess that's okay. Like, at the end of the day, I probably, maybe I'm just a little old school, but I probably wouldn't do this. And at the very least, you could probably, you know, these files are like a few lines of code, so you could just combine them into one file called SDL deleters, and then just have them all there. That would be a little bit more organized and would just reduce the amount of files you have to browse through. But I would probably just have like an SDL init function, an SDL shutdown function, like a renderer init, renderer shutdown, or whatever, application init, application shutdown, manually call all of them. That, for me, that just keeps it clean, because like with a lot of these things, like you have to be explicit with when they get deleted, right? Or shut down, right? So the order matters. And if you just have unique pointers that are in a stack, that can be obviously a little bit less explicit as to like the actual order. Anyway, though, I hope you guys enjoyed this video. Let me know what your thoughts were. This was a very long one, and this was a hard one for me because there was a lot of stuff to point out. And, you know, I mean, I didn't really get into the game logic so much. I more or less talked about the code and the code style and all the various problems it had. I hope that me solving some of these issues like the memory leak and showing how I approach that without ever having seen this code before, I hope that kind of stuff is helpful to you if you run into similar problems, and also maybe it will prevent you kind of prophylactically from writing that sort of code. Let me know what you thought in the comment section below. If you enjoyed the video, please don't forget to hit the like button. Let me know what kind of content you want to see next in the code review. Don't forget that you can email me at chernoreview@gmail.com. It will be in the description below with your code, a little bit of an explanation as to you know, whether you want to be anonymous or not and what the project is. And hopefully I'll see you in the next episode of the code review series. Don't forget to check out Skillshare using the link in the description below, and I'll see you guys next time. Goodbye.